Okay, 5.3, logarithms and logarithmic functions. This will be day number 1. In day 1 video, you are going to see an introduction of what logarithms and logarithmic functions are. You're going to see how they work. And you're also going to realize that they are inverses of exponential functions. So understanding what an inverse is, how to find it. Look, you're going to have to understand that we're going to start making tons of connections to where we've been and where we're going. So if you don't know where we've been down pat, then you're obviously going to struggle with where we're going. So please be careful. Understand everything you need to know about inverse functions, right? To find an inverse. I know I switched the x and the y values. So I know the domain of the original becomes the range of the inverse, and the range of the original becomes the domain of the inverse. Okay, so I know that those are inverses of each other. I know how to graph inverse functions, right? They simply reflect themselves over the line y equals x. So think about that. So what I'm going to tell you is that when I have it written as an exponent, I can solve it by taking the log, or what we're going to call the natural log of a certain function. But before we get too far, take a look at this first statement here. So I'm telling you, just like I just said, the inverse of an exponential function. Ta-da, there is an exponential function, right? We understand y equals a to the x is exponential. With base a is called the logarithmic function with base a, and how I write it is simply like this. I read this. I'm going to suggest you probably write this down. If you can read it properly, it's going to help you be able to solve them. I read that as the base A log of y. The base A log of y. Okay, so I can take an exponential function and write it as a logarithmic function. Okay, so hopefully you're ready to try some, see what happens. Alright, so what I'm telling you, let's go in the other direction. If I give you y equals the base 10 log of x, then what I can do to write it as an exponent, aka the inverse, I know what I can do is write it as the base 10, right? Base 10 to the y power equals x. Think about what I just did. I took the base, I set it, there is the exponent, and this is what it equals. Okay, so understand base, exponent, what it equals. All right, let's try some. I'm telling you, if you look at this first one, I'm telling you the base 10 log of 100 equals the number 2. Prove that the base 10 log of 100 actually equals 2. Well, in order to prove it, I know the inverse is to write it as an exponent, so I know what I can do. I'm going to take the base, I'm going to set it, there's the exponent, and then I'm going to set it equal to what it is. So do you see why the base 10 log of 100 is equal to 2? Well, it's equal to 2 because 10 squared is 100. Look at the next one. Why is the base 10 log of 1 over 1,000 equal to negative 3? Well, if I write it as an exponent, I know it's true. I'm proving it because 10 to the negative third power is 1 over 1,000. Okay, so I'm proving it. But now, can you work in reverse? It's going to be so unbelievably important that you are able to go from logarithmic to exponential or exponential to logarithmic. You're going to have to work in both directions. You just got to get used to it. Get over it. Stop complaining, right? Understanding you have to work in both directions. So what if I gave you 10 to the 0 power equals 1, right? I know 10 to the 0 power is 1. How the heck do I write that as a log? So here's what I'm thinking. I could write the log. I know it's got to be in base 10. I know I'm going to put a 1 there, and I know I'm going to put a 0 there, because the base 10 log of 1 is equal to 0, right? Think about working in reverse. Second one, why is 10 to the negative second power 0.01? I know some people, what they like to do is rewrite this as 1 over 100, right? Because that 1 is in the hundredths place, so I could write it as 1 over 100. Okay, so I know 10 to the negative second power is 1 over 100. Write that as a logarithm. So base 10 log of 0.01 equals negative 2. Hopefully that went okay, because there it is. I'm laying the foundation. Good news is that your calculator will do logarithms for you. Bad news is that your calculator will only do logarithms that are in base 10. It only knows base 10, so it has its limitations, but understand, when I write this on the board for you, when I write y equals the log of x, I want you to automatically understand that it assumes that when I write the log of x, it's assuming that it's in base 10. Okay, so if there's nothing written there, boom, it's got to be base 10. I know it's got to be in base 10 because that's what he told me, and that's what I'm sticking to. All right, let's keep going. So now, notice, everybody, it says to simplify this without a calculator, so you better not have your calculator next to you. So, to simplify it without a calculator, now I'm going to do exactly what I just did on the last page. I'm going to focus my attention on this thing right here that I did, and I'm going to see if I can kind of work in both directions. How I'm going to do that? Well, I'm thinking it's written as a logarithm, so I'm trying to figure out, well, what does it equal? Right? I'm trying to figure out what number this is. I know it's understood to be in base 10, that's why I put the 10 there. So I'm thinking, it's written as a logarithm. Maybe if I write it as an exponent, it'll help me begin to solve this. So let's do that. If I write it as an exponent, I get 10 to the x equals 10,000. All right, so from where we've been, I know that if I make the bases the same, I can drop the base and set the exponents equal to each other. So I know that what I can do is, well, I can take 10 to the x. I know 10,000 I could write as 10 to the 4th power. Voila, bases are the same. So I know that once the bases are the same, I drop the base and set the exponents equal to each other. I know, I'm in a weird mood today. So you get x equals 4. Great job. Nope, we're not done yet, so don't pause the video. Stop it. Stop it. Stop it. Okay. Next one, letter B. Again, write it as an exponent. So 10 to the x equals 1 over 10. All right. If I make the bases the same, I think I can do 10 to the x equals 10 to the negative 1st power. Voila, and therefore x equals -1. Okay, letter C. I told you if you want to write that as a fraction instead, great, I think you should do that. What would that be as a fraction? Hopefully you can figure that out, right? Tenths, hundredths, thousandths, 10,000ths. So I could rewrite that as 1 over 10,000. Alright, so 1 over 10,000, let's think, make the bases the same while I get to the answer, x equals -4. Okay, so, look, we're building. I'm piling on inverses, I'm piling on what we've learned already, and I'm going to keep moving. So if you're struggling, let's talk about it in class. Let's make sure we understand what's going on. And now, it's time. Fantastic job.